Drawing a segment bisector allowed me to come up with a strategy for finding the midpoint of a segment. This triangle, which has already been drawn, is made up of 3 segments, and I'd like to find the midpoint of each of those sides in order to locate a way to draw medians. Medians join a midpoint of one side to the vertex opposite that side. So I'm going to open my compass so that it is of a wider opening than the distance from A to B, and I will bisect this segment, or at least I'll begin this segment bisector construction. Need a little more on this side. And this allows me to know exactly where the midpoint of the segment is. Because if I drew the whole segment bisector, I would find that its crossing with segment AB is right here at the midpoint. I'm going to repeat that exercise, bisecting segment AC. And I'll pick up my straight edge again, and I can see that if I were to draw a segment or a line through these 2 intersections, I would find that that segment or line would cross segment AC right at its midpoint. So that's how I find midpoints. Now I mentioned that medians are the connection of a vertex with the midpoint of the opposite side. I'm going to draw all 3 medians, so I need to find the 3rd midpoint, or the midpoint of the 3rd side. So I'm going to open up my compass so that it's more than halfway from point B to point C, and with the same compass opening, make a mark on each side. Sometimes you'll find that you need to go back and lengthen one of your arcs. So now I know that if I were to join this crossing and this crossing, those 2 intersections, I would find exactly where the midpoint of segment BC is. So I'll label that midpoint 3. Now if I join midpoint 1 to the vertex of the triangle ABC that is opposite side AB, that will mean joining that midpoint to point C. I'm going to do the same thing, joining vertex B to the midpoint of the side opposite vertex B, and once more joining A to the midpoint of the side opposite. And what I find is all 3 medians cross at a particular point. In any triangle, acute or obtuse or right, if I draw the 3 medians, and the medians once again are segments that join a midpoint of a side of a triangle to the vertex opposite that side. So in any triangle, when I draw the 3 medians, I find that they concur. They share a point of intersection, and that point is called a point of concurrency. This particular point of concurrency is called a centroid.